Hey everyone, in this video I'll be showing you guys how to make a simple AND gate with two inputs and one output using the schematic on VHDL, and I'll be showing you guys how to edit a UCF file and program the Xilinx board. In this run I'll be using the Nexus 3 Spartan 6 board. Okay, so let's get started. The first thing you want to do is click New Project. So you can either do it from here or you can go in File, New Project. Alright, so let's do that. Right, so here is the window that comes up when you click New Project. You will have to enter the name of the project, so let's name it AND Gate, right? So this is the location, right, that is set, right? So I set it to the bin folder in my Xilinx file. Sometimes certain locations are inaccessible, so you just have to, most likely you'll have to go into the Xilinx folder itself in your computer, alright, and select the bin folder there. It should be easy to find, right? So you just follow this directory and it should be there, assuming you have 14.7. But it should be a similar directory for any version that you have. Alright, and you want to make sure that schematic is selected. So we just do that. And you click next. And here is where you specify the board specifications. So in this case, nothing needs to be changed since I've used it with this board before. But if I needed to change something, I would be changing these three things: family, device, and package. The family, in my case, is Spartan 6. The device is this one, and the package is this one. Now, all of these would be specified on your respective devices, the packaging, or the chip itself on the board. So mine is showing the device number, right? I'm not seeing the package number, right? But you should check the packaging of the board, the physical packaging, right? Mine came in a cassette case, right? So you just look for that, right? We don't need any simulation tools for this tutorial, but if you were using it, you would use either Model Sim or iSim. Usually we would use Model Sim. So let's go ahead. Next, and this is a summary of all the things that you chose, and finish. Right, so this is what you see when you create your project. Okay, now this here it represents your device. So what we want to do, we want to create a new file. What we are going to create is a new schematic file. So you could either click New Source, or Add Copy of Source. New source is creating something from scratch. Add source is to add an existing source from somewhere. Now, using this option, you would be changing the contents of that file. If you add a copy of a source, you're basically adding a copy of a source from its current directory into the working directory of this particular project. So you would be editing a copy of the source and not the actual source. So let's create a new source. All right, we select schematic and let's name it AND Gate schematic something. All right, make sure add to project is there. Right, finish. And here we are. We have the grid to add our devices onto and make our schematic, right? And let's do that. So here we are going to go in symbols, so add symbol, and these are the symbols here and the categories, so you can sort them or you can just click all symbols and search them. So just type AM in quick succession and it should go to the AND gates immediately. right? So in this case, you want a 2 input pin. So double click and drag, click. Let's zoom in a little bit. Right. So that's that. And you notice that it still has a shadow following my mouse. Just right click to get rid of that. Okay. Now, we have to specify what the inputs and outputs are because the program wouldn't know what to do, right? So to do that, we add tags, right? Input, output markers, right? And we just click, click, click. Simple enough, right? Now, these are the default labels of the markers. Now, we can leave it as is, or we can specify it. We can specify our own, right? So right-click each label and specify a name. So I'm going to name this one A. I'm going to name this one B. And intuitively, I'll name this one C. Right? This is from using any numbers because you don't want to confuse anything or mess up anything, right? That could cause some problems. Okay, so now that we have a schematic, right, on board, right, we'll want to specify something called a UCF file for this, or a user constraints file. Okay, now what that does, it basically tells the board, okay, the inputs go to this part and this part, and the outputs go to that part. Simple, right? So in this case, we'll be using switches for these two and an LED for this one, right? So there are two ways you can do this. You can either add a new source and then select user constraints file, right? It's named implementation constraints file over here, right? You could either do that and a totally empty file will come up under here, as I will demonstrate. Right, so you'll see another file in the hierarchy there, and I could type in my stuff. I can do this, or let's remove that. Now removing it doesn't delete it, it just removes it from the hierarchy. Or I can add, right, I can add a master UCF. Now, master UCFs exist for all your boards, right? So this is the master UCF for my Nexus 3 board. Okay, notice that everything is green, which means that everything is commented. So I just need to uncomment what I need, right? In this case, I need switches and LEDs. Okay, now the net, wherever you see, let's just uncomment this, right? Wherever you see net, right, that specifies the name of your input or output, right? Location specifies the actual location on your board of that particular input or output peripheral. So notice that they have default names and they have the actual locations, right? So let's look for our switches and LEDs. Okay, here we are. So we have our LEDs here and our switches here. So we have one output, so let's use one LED, and the name of that output is C, as you can remember from the schematic, C, right? And our inputs are A and B. Doesn't matter which order you put it in, just know which one goes to which. Okay, right, so we have specified that. Okay, now this is from the master UCF. It seems much simpler because you don't have a bunch of syntax to remember and stuff like that. Normally, when you specify your own UCF, you don't put all of this. Okay, now let's go to our empty UCF. If I wanted to edit this file, right, I would type in net. I'm basically copying whatever I see here. So net A, right? And then LOC equals, and the location of that pin, right? So I'm using A, so I want to send that to a switch, one of which T10, one of which is T10, right? So notice that, well, not notice, but this is not case sensitive, so I could have put a common T, it wouldn't make a difference. All right, so basically I could just copy this into here. All right, and it would work just as well as my master UCF file, but we're not using this, right? You can try it out for yourself and see if it works, and it should, right? But for this purpose, we'll be using the master UCF. Okay, so I want you to notice that when there's an asterisk by the name of a file in the tabs over here, that means that the file has changes that needs to be saved. So you can just click save for each individual file or save all. So notice I have an asterisk here and an asterisk here. If I click save all, right, it will give me all the files that need saving. So the next is 3 master UCF and AND gate. Just make sure you select all, and there we go. All right. So that's that. Now to program the board, right? What we do, we select our top module, right? Notice it has, right? So this is our top module, the one with this symbol here, the 3 chip things, right? Now, I would like to synthesize my design, right? Then implement it, which means mapping it to the board and stuff like that. So this is translating it to lower level language, mapping it and placing it and routing it to the board. So I'm not connecting to the board, I'm just saying, okay, the program is saying, okay, I'm putting this there and that there, right? Programming file, that is generating the programming file that the board could understand. And configure target device is where I actually send that programming file to the board, right? Now I want to go straight to here. If I double click synthesize, it will just synthesize. If I double click implement design, it will just implement design, right? After it synthesizes. But I could just double click configure target device and it will go synthesize, implement, generate, configure, right? So let's double click here, right? So there are 4 symbols that you'll see. This spinning symbol means that a process is running, right? So you see running synthesis, and you should see a green tick, right, when it's finished. That green tick would symbolize that everything is okay. There are no errors, right? Everything is fine. So it's running translate right now, right? This question mark means that there's processes running under this. So you see that these are sub-process in implement design. So there are sub-process running. That's why the question mark is there. The question mark may also appear if you make changes to a file, right, after you synthesize. So now it's generating the programming file and it has finished. Now we double click configure target device. The other symbol that you may see is a red X, right? Now if you see a red X, everything would stop and you would have some errors to correct, which you can see over here in the errors tab. All right, so my impact was opened, right? If let's just, right? So impact is open, right? What I have to do now is double click boundary scan, right? And follow the instructions right here. Initialize chain. right? Now, notice that they said cannot find cable, right? That means that my board is not connected and powered. Now my board is connected, but it is not powered, so I'll power it up right now. It is now powered, so let's initialize chain again, and there we go. Right, now if you see this, right, this is just asking you, do you want to add the bit file now? So yes, let's do that. Right, so we see it takes us to our directory, our working directory. Now let's look for the file. This is the file that we created, right, and this is the programming file. It would be a .bit file. So open that, right, select no for this option, and OK. Right, the next step to do, and the final step in getting your stuff to work, is right-click this and program. Alright, so this is the board, right? As you can see, we have the switches here that we programmed, T10, which is right there, and T9. So these are the inputs to the AND gate, and we have the LED that we are using, U16, right, that will light when both switches are on. Right, so if we turn on this switch only, the LED should be off. If we turn on the other switch only, it should also be off. If we turn on both of them, the LED comes on. Right, and that signals that our program is working.